Now we will take our sum and difference formulas and broaden their use. So let's imagine that we have two angles, alpha and beta. The sine of alpha is 5/13, and you'll notice that alpha is between pi over 2 and pi. That means that alpha is in the second quadrant. And you'll notice that cosine of beta is 7/25, and beta is between 3 pi over 2 and 2 pi. That means that we are in quadrant 4. So let's go ahead and look at sine of alpha minus beta, which we know is nothing more than sine of alpha cosine of beta minus cosine of alpha sine of beta. To figure out each one of these individual components, let's sketch alpha and beta in their respective quadrants. So we know that alpha is in the second quadrant, and we can drop a perpendicular to help us out, and we know that the sine of alpha is 5/13. So we can use our Pythagorean theorem, or the fact that 5, 12, 13 is a Pythagorean triple, and we know that to complete that Pythagorean triple we have 12, but then because it's on the negative x-axis, we can make that a negative 12. Likewise for beta, we know that this is in the fourth quadrant. And we can again drop a perpendicular to our x-axis. And we know that cosine of beta is 7/25, so adjacent over hypotenuse. And our Pythagorean theorem would yield 24, or we know that 7, 24, 25 is a Pythagorean triple. Because this is on the negative y-axis, we can make this negative 24. So now we can go ahead and write the sine of alpha minus beta equals the sine of alpha cosine of beta minus the cosine of alpha sine of beta. The sine of alpha we were given, and it's 5/13. Cosine of beta we were given, and it is 7/25. Minus the cosine of alpha will be negative 12/13. And the sine of beta will be negative 24/25. So we obtain 35 over 325 minus 288 over 325, which equals negative 253 over 325. Now in this next example, we again have a trig function and we have a difference. So you'll notice that this is the difference, and the output of an arc sine is an angle. So let's call sine inverse of 3/5 alpha, and let's call cosine inverse of negative 5/13 beta. So what we have here is nothing more than tangent of alpha minus beta. So let's go ahead and sketch alpha. We know that since sine inverse of 3/5 is alpha, that means that sine of alpha equals 3/5, and alpha must be between negative pi over 2 and pi over 2. Because sine of alpha is positive, that means that alpha must be in the first quadrant. And again, we can drop a perpendicular to our x-axis, and this means that we have 3/5, and this is a 3, 4, 5 triangle. Now, let's do the same thing for beta. We know that cosine of beta equals negative 5/13, and this time, because we're dealing with the range of arc cosine, beta must be between 0 and pi. Since cosine of beta is negative, beta must be in the second quadrant to be between 0 and pi. So again, let's drop a perpendicular to our x-axis. In cosine, this will be 5 and 13, but since we're on the negative x-axis, we'll make that a negative 5, and either using a Pythagorean triple, 5, 12, 13, or the Pythagorean theorem and determining that that is a 12, we can now find the rest of our tangent. So the difference formula for tangent will be tangent of alpha minus the tangent of beta over 1 plus tangent of alpha tangent of beta. So tangent of alpha from our picture is 3/4 minus, now the tangent of beta will be negative 12/5 all over 1 plus the product of those two, 3/4 and negative 12/5. And so we have 3/4 plus 12/5 over 1 minus 9/5. Now, the trick to simplifying a compound fraction is to multiply by the LCD of the fractions. So here we have a denominator of 4, 5, and 5. So the common denominator of those three is 20. So we'll multiply the numerator and denominator by 20. If we do that, we would get 15 plus 48 over 20 minus 36, which equals 63 over negative 16. So we can write that as negative 63/16. Now let's establish an identity. So remember, with establishing an identity, we take the left-hand side and we use trigonometric identities known to us and algebra as necessary to manipulate the left-hand side until it becomes the right-hand side. So cosine of alpha plus beta, we can use cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. So what we have at this point is we've rewritten this portion as this. Now let's rewrite cosine of alpha minus beta. So plus, that plus sign is this plus sign. And now cosine of alpha, cosine of beta, plus sine of alpha, sine of beta. Now we have a negative sine alpha sine beta, and a positive sine alpha sine beta. Those will add out to 0. And then we have a cosine alpha and a cosine beta, and a cosine alpha and a cosine beta. So we have 2 of them. And we have the right-hand side.